Hey everyone, today I am going to reveal some hidden facts about I-beams. An I-beam is a widely used shape of structural member that can be seen in both heavy machinery and static constructions. It contains two flanges connected by a vertical web, providing an excellent strength-to-weight ratio. The horizontal elements are called flanges and the vertical element is known as the web. The web resists shear forces while the flanges resist bending moments. Let's dig into the various types of I-beams and their applications. We'll also glance through the manufacturing processes of I-beams and the materials. There are three types of I-beams based on their cross-sections. The first one is the standard Y-beam, commonly known as the S-beam. The flanges of the S-beam are tapered and get thinner further from the web. They are ideal for lightweight applications like roofs and smaller structures and are also seen in heavy machinery. Because of their cross-section, they are best suited for supporting loads acting normally on the flanges. The second type, wide-flange beams or W-beams, have wider flanges than the standard IY beam and the flanges are not tapered. They're perfect for applications requiring higher load-carrying capacity and resistance to higher forces. They are used in bridges, warehouses, and large industrial facilities. The main chassis of certain heavy machineries, such as huge blast hole drills to trailer trucks, are often constructed using W-beams. And here comes the last one, the H-beams or universal columns. This beam is known as H-piles or HP in the United States. These beams have equal or almost equal width and depth, making them suitable for carrying vertical axial loads. They are mostly used in residential and commercial buildings as columns. Now let's discuss materials. I-beams are commonly made from structural steels of various grades. ASTM and 992 is the most common steel grade used for W-beams in the United States. N10024 and N10162 standards are used in Europe for hot and cold rolled I-beams. Apart from structural steels, for low-weight considerations and special applications, aluminum or composite I-beams are also used. Wood with fiberboard or laminated veneer lumber is gaining popularity in residential constructions. Plastic Y-beams are also available in various shapes. When it comes to manufacturing I-beams, fabricated I-beams are the most common to see. Custom fabricated beams provide precision, flexibility and creativity. In some cases, varying section beams are also designed for optimum weight and load considerations. Hot-rolled and cold-rolled beams are constructed from one whole piece of metal and are available in standard shapes. If non-standard shapes are required, the entire manufacturing setup has to be modified, which is suitable for large order quantities only. Aluminum Y-beams are manufactured by extrusion. Though the I-beam is a strong contender in structural applications, it also has limitations. Because of its reduced cross-section, it is poor at carrying torsional loads. For torsional loads, hollow-sectioned structural members, such as square and rectangular tubes, provide better results than I-beams. So far, we have gone through the three types of I-beams and discussed the materials and manufacturing processes. Now let's discuss a design topic. Have you ever wondered why the web of the I-beam is thinner than the flanges? Any guesses? To find out the reason, you should have a basic understanding of section modulus and bending moment. A beam under bending experiences high stresses along the axial fibers that are farthest from the neutral axis. To prevent failure, little material is needed in the area close to the neutral axis. This is why the flanges are much thicker than the web. Now, let's talk about the designation of I-beams. In the United States, steel I-beams are designated using the depth and weight of the beam in inches and pounds per foot, respectively. Canada uses the same parameters in metric units. The units are millimeters and kilograms per meter. The designations vary from country to country. Finally, we have arrived at the end of this session. Please share your thoughts about this video in the comments section. I will be posting more videos which will help in understanding various aspects of mechanical engineering and more specifically about heavy machinery. If you don't want to miss them, don't forget to like, subscribe and hit the bell. See you next time.